take a look at worksheet 1.3, page 1 here. The first question is just, can you take a look at a different sequence as a recursive definition and identify the type it is, if it's increasing, decreasing, leveling off, and does it give you a linear or non-linear pattern? So when I look at the first one here, what I'm going to take a look at is, am I adding, am I multiplying, or am I doing a combination of both? So on this first one here, notice how I'm just only multiplying. So that tells me that it is geometric. Now, taking a look at, is it increasing, decreasing, or leveling off? Since this value right here is less than 1, it causes it to decrease. So this one is decreasing. Last but certainly not least, is it linear or nonlinear? Geometric and nonlinear go together. I'll give you a curve pattern. So this one is nonlinear. All right, let's take a look at number 2. Number 2, notice how we have multiplication, but we also have some subtraction going on. Anytime you have both pieces happening, that's the shifted geometric. Okay. Now, the next part is this increasing or is it decreasing? Sometimes that's challenging to figure out. So sometimes what I will do is take a look at what happens to that next term. So what I might do is use my calculator here. I'm just going to exit out of this screen here and type in 200 and say, all right, what happens if I multiply this by 1.04 and subtract 15? Did it go up or did it go down? This one actually goes down. So this one is decreasing. Now, one of the helpful hints, though, that it could have been decreasing is I was subtracting, and 4% of 200 is not more than 15, so I knew it was going to go down. Since it contains the word geometric, shifted geometric is also nonlinear. The only one that's linear is the arithmetic. So let's take a look at the next one. How about that? Just as we get right on it, it's this next one here. I'm only subtracting 6. So this one is arithmetic. Since I'm subtracting, it's still going down, so this one's decreasing. And this one here is linear. Remember that arithmetic and linear go together. All right, so our last one here, we're multiplying and we're adding. So this one here again is a shifted geometric. Now the question becomes, and so I can also write here nonlinear right away. Question is this one increasing or decreasing, or could it actually be leveling off? So I'm actually going to go back to that previous one, number 2, where I have this, because I see it at 193. But if I times it by 0.04 and subtract 15, I'm going back to that second one here. One of the questions is, I didn't really check to see if it's leveling off. So as I'm doing this, notice how as I'm going down, it's decreasing and decreasing at a faster and faster rate. So the amount in between, see how it's about 13 apart, 14 apart. So that's why I know it was always decreasing. But when I do this last one here, I'm going to start at 50, I'm going to times it by 0.96, and I'm going to add 100. So now I'm going to use my last answer feature, so I'm going to times it again by 0.96, and I'm going to add 100. So if I hit enter here, and I keep on hitting enter, what you start to notice is, yes, it is increasing, but what it will do is it should start leveling off eventually here. Notice how the amounts, it's getting a little bit smaller and smaller. So sometimes it takes a lot of time and a lot of enters to see where, but you can see it's getting smaller and smaller, and it will eventually here level off. We'll show you in a minute again how we get them or find out where it levels off to. All right, moving right along, let's take a look at number 2 here. Number 2 says you have $25,000 in a bank account. Each year you withdraw 8% of the balance and deposit $1,200. So it says write a recursive formula for the situation. Notice how you are doing two things. You withdraw 8% of the balance and you deposit $1,200. So with our recursive definition, there's going to be two parts to that second piece. However, we always start with our starting value. So we initially deposited $25,000 into the account. So now use of n minus 1. The first thing we did was we withdrew 8% from the balance. So to withdraw, okay, we're going to take 8% and we are taking it away. So we're going to subtract it. So we're going to go 1 minus 0.08. Now if you put 0.92 here, I'm okay with that. In fact, lots of times I will do that. However, we decided to add $1,200 after it. Okay? So now, the next question asks, use algebra to determine the amount of money you have in the account in the long run. Now we talked about this today in class. To get the long run value abbreviated, you take the adding amount and divide it by the percent of decrease. So the starting, or I should say the adding amount, was $1,200, and you're dividing it by 8%. So if we do that on our calculator, this should level out at $15,000. So if you don't believe it, and you're not convinced, or you want to even check your answer, you can start by saying, all right, I can take 25,000. I'm going to times it by 0.92, but add 1,200. That will tell you how much is in your account after the first time. Times it by 0.92, but add 1,200. Now, you can see that it is going down, but the question is, how far does it go to 0 or not? So I can keep on hitting enter. Notice how it's getting smaller and smaller, or the decreases are getting smaller and smaller, and it's starting to level off pretty soon. See how it's now at 15,000? Well, let's see if it'll keep on taking my enters. And it basically will get there, and you can see that you're at 15,000. All right, let's take a look at the last one here on the page. Same type of problem. You have $75,000 in a retirement account. Each year you withdraw 6% of the balance, but you're able to deposit, again, $12,000 from other investments. So this time, instead of 1,200, it's 12,000. So we want to write the recursive definition. Again, how much did we start off with? Wow, $750,000. That's a nice retirement account. So now each year, you're able, or you're going to take out 6%. So you're going to subtract out 0.06 from that 1 that you're multiplying by. However, you had other retirement accounts or other investments, and you're able to add back in $12,000 into the account. So we got our recursive. So part B asks you to find the long run value. So just like we did before, long run value is equal to the adding amount divided by the percent of decrease So in this case, our adding amount was 12,000, and we're dividing it by 0.06. And in this case, we can keep on doing this for a very long time, and we'll still have at least $200,000 in our retirement account. So that ends page